Hello, everyone, and welcome to 16.2 Lewis Structures Part 2. In the first part, we looked at the basics of Lewis structures for covalent bonds, and this will be more specific cases and some other things you need to know and be able to draw for Lewis structures. The first is a concept called resonance. Resonance specifically is how the actual structure of a molecule is actually a composite or average of the number of Lewis structures that could be drawn for it. And each of these individual Lewis structures that can be drawn are each called resonance structures. So if we look for an example here for NO3, there's the oxygen double bond could be placed on this oxygen. It could be placed on this oxygen, or it could be placed on this oxygen over here. Nothing about nothing about it dictates that the double bond should go on a specific oxygen. It could go on any of them, and it still satisfies all our rules and makes a stable compound. So we say that each of these are resonance structures of the full compound. So the compound is all three of these at the same time because all three of these could exist. As an example, let's go back to what we looked at last time, which is CO3 ion. This is how we drew it last time with its charge. But like I mentioned, why we just randomly put the electrons on these oxygens and then had this one be a double bond. But there's no reason that has to be the case. We could move a lone pair of electrons to form a double bond here and move this double bond to be lone electrons here. And then that also is a valid structure. To denote resonant structures, to say that they are one, you draw this double-sided arrow. If you don't draw the double-sided arrow like this, you will lose marks for it. You have to draw a double-sided arrow. But it also could go onto this oxygen here. So we would write it like this, because the double bond could be on any one of these oxygens, and it still makes a stable ion. So this is the full Lewis structure. You would draw all three of these with these double arrows going through them. And that is resonance. Next, let's talk about coordinate covalent bonds. This is a covalent bond where both electrons that form the bond are from the same atom. So instead of each one having an atom, giving an electron, only one of the atoms gives two electrons that is shared between both. So the first atom is already stable, it's already happy, but then it shares two electrons to make another atom also stable. An example here is carbon monoxide. So carbon has 4, oxygen has 6, the total is 10. To do how we would draw it, normally you start with the carbon, oxygen, put a bond, put their valence electrons on the outside. Neither of them are happy right now, so you form a double bond. But now oxygen is happy. It has 1, 2, 3, 4, 5, 6, 7, 8. But carbon isn't happy. It only has 4, 6. So what could happen here to make the carbon stable is that oxygen brings down 2 of its electrons, a lone pair, and forms a triple bond with the carbon that now makes it stable as well, because now it has 8 electrons. To denote a coordinate bond, you write it as an arrow instead of just a line, where the arrow shows where the electrons are coming from and then where they're going to. So in this case, they're coming from the oxygen, so the arrow is pointing towards the carbon. Then, just to make it cleaner, because of how the 3D structure looks, you would probably write it more like this, with the lone pairs being put on the outside of it. It just makes it more clean to look at, because that's more how the structure would actually look. Again, you don't need to do this, but it's good to get in the habit of writing things like that. All right, that's the end of this video. Thank you guys so much, and I'll see you in the next one.